Alright, good afternoon, students.
Good afternoon, sir.
Alright, today we are looking at experiment 3 today. Last class we looked at experiment 2, that is on leaf microscopy, and today we are looking at experiment 3. This is from the chemistry aspects. Last class was from the biology aspect, but we asked to report in the same report notes, just as we were to save cost. So we are looking at titration today. That is the title of the experiment we are looking at today. The title is what? Titration. Now the aim is to determine the concentration of a known solution using a known solution. Are you following?
Yes.
Now, before we go further, let me explain the meaning of titration word to you. Titration is a technique in chemistry in which a known concentration of a solution is used to determine the concentration of an unknown solution. As a matter of fact, when we are talking about titration, we are looking at two solutions, an acid and what? A base. An acid and what?
A base.
Now, we are going to look at the color change and what the end point of what? This acid-base what? Reaction. That's what we call what? Titration. If we don't call it titration, we call it what? Volumetric what? Analysis. In fact, in WAEC, it is number 1 question every year in what? In WAEC. Now let's go further. Let's see what we have. From the board, we have apparatus what? And materials. We have burette, we have pipette, we have conical flasks, we have beakers, we have glass funnel, we have volumetric flasks, we have hydrochloric acid, HCl, we have sodium hydroxide, NaOH, we have distilled water, we have the rectus stand, and we have what the indicator called the titrant. Now, this is a procedure. I've told you from the last class that all practicals have what? A method or a procedure we use in what? In arriving what? At a particular observation or an answer. So today we are going to look at what the procedure. Now this procedure is from 2021 chemistry practical. It's from what? 2021 chemistry what? Practicals. That is what we are looking at today. Now let's say the procedure. A is a solution containing 5.00 gram of HCl in 500 cm cube solution. B is a solution of sodium hydroxide of unknown concentration. And the structure is here. Put A into the burette and titrate it with 25 cm cube portion of B using material as an indicator. Now, repeat the titration to obtain concordant titrant values. Tabulate your results and calculate the volume, the average volume of acid what used. Now, an equation is given on the board, reacting with what? Sodium hydroxide, a base, to produce what? Sodium chloride and what? And water. BI says, write a balanced equation of the reaction. From here we say, from your results and information provided, calculate what BII, concentration of A in mole per gm cube, BII, concentration of B in mole per dm cube, IV, calculate the relative molecular mass of what? The acid, HCl. Where hydrogen is equal to 1, the mass, chlorine is equal to what? 35.5, the mass. Now, the next thing is a what? Observation. Is what? Observation. What this method or these steps are giving is what we call scientific what? Method. In carrying out or in writing what? A report, a practical report, there are some steps you what? You follow. These are the steps. I'm taking them step by step. Now, the next one is what? Observation. Once you have done all this, according to the procedure, you what? You observe. And I've told you in acid-base titration, your observation lies on what the color change, which is nothing what? The change in color lies in what? Observation. Now, the next thing is what? Is precaution. The next thing is what? Is precaution. Every experiment has what? Its own precaution that must be what? Put in place. The precaution ensures what? A better result at the what? End of the day. These are the what? The guidelines, the safety measure you must ensure, you must put in place to make sure you what? Your result is accurate or your practical is what? Is accurate. Now, there are so many precautions that are what? Following these practicals. There are many what? Precautions following what? This practical. Titration, so to say. Are you with me? Like one of the precautions, when you are using the burette, it's advisable for you what? To rinse with water and as well as what? The acid which the burette is going to what? To hold. If you are using a pipette, which is using what? In pipetting the base, It's advisable for you what to also rinse it with water, distilled water, and as well as what the solution it is going to what to hold. The pipette is holding the base, because we're taking 25 cm cube of the base or 25 ml. 25 ml is still equal to what? To 25 cm cube of what? Of the base. Are you with me? Then once you carry out this experiment, as you're turning the acid using it with the aid of the funnel, the glass funnel, before you start your titration, it's advisable for you what to remove the funnel. These are some what precautions. Now, on that measure precaution, once you're what preparing your solutions, for example, you're preparing what the acid. One of the precautions we normally take is this: acid dissolve in water, not water dissolving what in acid. What does it mean? You don't pour water inside what? Acid. You don't pour water inside what? Acid. But you pour acid inside what?
Water.
Are you following? This is one of the precautions, because acid dissolves in water to produce hydrogen ion as the only positive ion in what? In the solution. So you turn acid inside water and not water into what? Acid. Very, very what? Important. This is to avoid what? Splashes. Are you with me? And to avoid what? Burn. That's one of the major what precautions what you take. Are you following?
Yes.
Now the next thing is what? Is your conclusion. Is your what? Conclusion. All experiment is what? Is concluded in respect to what? To the aim. You conclude your experiment. I've told you from the last class, from the last experiment on biology, I've told you conclude in respect to what? Your aim. Are you following? So now we have gotten all the steps and I've explained all to you what we have to work to carry out. Now we'll go to our workbench and see what we have. Now this is our workbench. The solutions are already prepared. Here is our HCl acid. Here is our sodium hydroxide. Here is our indicator, the material. Here is our titrating flask or the conical flask. Here is our pipette. Here is our beaker, and this is our distilled water. This is my stock solution for my material. Now we are going to start, but before then I will go over to the board again. I will go over to the board. Remember they said put A into the burette and titrate it again with 25 cm cube of B using what? Material and what as an indicator. Repeat the titration to obtain compounded titrant values. Tabulate. What I want to do on the board is what? Is tabulate. Now I will tabulate it now. Because that is our instruction. Tabulate. This is our first titer, and this is our second titer. All in cm cube. From your sentence, it is advisable for you what to do this using what? A ruler, or permit me to use what? A freehand sketch. Because to this video. Now, this is our table. Now the volume of pipette is 25.00 cm cube. That is our volume of what? Pipette. 25.00 cm cube. So now this is our rough in cm cube, our first in cm cube, our second in cm cube. Final direct reading, initial direct reading, and volume of acid what? Use. Now when doing this, ensure to put everything in what? In two decimal place. Into what? Decimal place. Your value should be what? In two decimal what? Place. Are you following? Yes. So now, for the rough titration, our initial is going to be what? 0.00. 0.00. In cm cube, cm cube is there. Now we are going to check it. That's our initial. Let's see what we have under the rough. Let's go back to our table. Our workbench. I've told you before, this is our HCl, our acid, this is our base, and our indicator, material. This is my stock solution from that. Now, this is my base. I'm going to prepare 25 ml of the base. Enable me to turn it into my beaker for easy pipetting. I'll pipette with 25 ml of what? The base. This is my titrating flask, the conical flask. I've pipetted 25 ml of the base. I'm going to tighten my tap while I introduce my acid with the aid of the funnel into the burette. I want to make sure this is at 0 mark from the burette. That's the calibration I'm using. Now this is at 0 mark. You can see it here. That is at 0 mark. Now I'm going to introduce two drops of the indicator material. 2 drops, 1, and this is 2 of my indicator, and this is our starting point. Please note this coloration. This is our starting point. This is red color. The indicator of the color of the indicator, the material is red in color when introduced into the 25 cm cube of what the base. And this is what we have. Note this color so that you can be able to detect your color change during water titration. Are you following? This is the remaining part of my base solution, sodium hydroxide. So I'm going to titrate it now. Titrate by what? Swelling over, continuous shaking until you note a change in color. Now, from the titration, there's already change in color. These are our endpoints quite different from what we had from the starting. Is our endpoint. There is a color change. It shows that neutralization what has taken place. Are you following? It shows that what neutralization has taken place. Are you following? Yeah. Now from the rough reading, and then just let me discard this into here. For the rough reading, our endpoint or the final direct reading is at 10.00. The final is what? 10.00 cm3. That is the final from our rough titration. Our rough what? Titration. The initial was what? 0.00. The final is what? Is 10.00. Please note all this. Note what? All this. Now, we'll go to what? The first titration. We'll go to what? To the first what? Titration. We'll start again. I'm going to fill up the word, the direct to what? To 0 mark, just for what? Accuracy sake. For accuracy what? Sake. I'll still take it again from what? 0.00. In the first reading. Now let me raise my titrating flags. I'm going to fill up again to 0 mark just for accuracy. Now you can see that this is above 100. I'm going to release it. I want it to be at 0 mark. I'm going to release it. This is a 0 mark. Sorry for the first. I didn't take away the what? The funnel, the glass funnel. So I'm going to do that right away before titrating. Now I'm going to take another 25 portion of the base again. From this, I'm going to prepare another 25 ml of the base. Please, one of the precautions you need to get is while pipetting, try to what? Avoid air bubble. Try to what? Avoid air bubble within what? The pipette. Now I'm going to release it. Correct. Is around 25 ml of the base or 25 cl cube of the base into my titrating flask. I'm going to introduce 2 drops of the material. The indicator is 1 and this is 2. Now this is what we have. This is our starting point. We are going to take it gradually to what? We notice a different color from this, our starting point. We are going to titrate. Do it gradually. Be noticing that it is changing gradually. Add drops by drops. Add drop by drops. Now, if you look at here, there is a color change here, and this is what the endpoint. At every endpoint, you notice what? A color change. Are you following? Are you following? Now I'm going to discard this. I'm going to take my what? My Burette reading. I'm going to take my Burette reading. I was having the lower menu course. It is still 10.00 from here. That means if I still have 10.00 from what? In the first, I can as well manipulate it in the second what? Burette reading. Are you with me?
Yes.
Because from here it's still 10.00. So the final here in the first reading is 10.00. Is that cube? Now we are going to take for the second reading. We are going to take what? The second reading. But before we do that, since we are not making use of the rough, we are going to cross the rough. We are going to do what? Cross the rough. Now the difference between this and this is still 10.00. We are going to cross it because we are not making the what? The rough. Then we are going to do what? Our final titration. We are going to do what? Our final titration. Now I'm going to rinse again with distilled water. Rinse my conical flat with distilled water. With the aid of the funnel, I'm still going to fill up to the 0 mark. Now that is above. I'm going to release it. Now these are 0 mark. I'm going to take off my funnel. I'm going to pipette another 25 ml of the base. I've told you this is my base. For easy pipetting, I will still fill up this. This is another 25 ml portion of the base. I'm going to introduce 2 drops of my indicator, my methyl red. This is 1. That is 2. Now this is our starting point. You know the color. Our starting point. I'm going to titrate. Now this is our final, our end point. This is 11.01. Remember our initial in the second is what? 0.00. The final is what? 11.01. Now we're going to look for the difference. Now from there, it said put end on the bread, titrate with what? Titrate it with 25 portion of base using methyl red as what? Indicator. Repeat the titration to obtain what compounded data value, tabulate your result, and calculate the average volume of acid water used. So before we calculate the volume of acid used, let's get the difference between the final and what the initial. Here is 10.00. This is what? 11.01 minus 0.00. Those of you that have calculator, do it for me, let me see. 11.01 minus 0.00. What do we have? 11 point what? Who is doing the calculation for me?
11.01.
11.01. Now, I've told you we are discarding the what? The rough. We are not making of what? The rough. So we are going to take only the two titrant values or the two compounded what? Values. Are you following? So now, to calculate the volume of acid used according to what the instruction, we say that volume of acid used is equal to the first titrant plus second titrant, or in cm cube. So this will be equal to 10.00 plus 11.01, or in cm cube divided by what? By 2. We are dividing it by 2 because we are making use of what? Two concordant titrant word values. The first and the second word direct reading. We are using what? The first and the second word direct word reading. Are you following?
Yes, sir.
So now, yes, you have calculator, help us. 10.00 plus 11.00. What do we have? 10.00 plus 11.00. What do we have? 21 point what? Okay. 21 cm cube divided by what? By 2.
10.5.
Is what?
10.5.
10 point what?
5.
5 cm cube. This is now our what? Volume of acid used. They said calculate what? The volume of acid used. Now we are through with what? A. We are through with what? A. Are you following?
Yes.
We are through with what? A. In A, the instruction here is what? To tabulate and calculate what? The average volume of acid water used, which we have done, which we have what? Done. Are you following? So, enable me to what? To wipe up what? This area, so that we can continue with what? The rest. Please note this, our volume of acid used is what? Is 10.5 cm cube. Now, this is the equation of reaction which I've told you before. We are asked to write a balanced equation of what? Of the reaction. That is BI. Write what? A balanced equation. Now this is HCl plus sodium hydroxide. We have sodium chloride plus what? Plus water. Now when you're asked to write a balanced equation, it's just to balance the atoms of the component elements what's involved. You take the left hand side and the right hand side. Whatever you have in the left hand side will be equal to what you have in the right hand side. Are you following?
Yes.
Now you just look at the atoms of the element. Now you said left hand side. The reactant is called the left hand side. The product is called what? The right hand side. Now the element from the reactive, we have hydrogen, chlorine, sodium, and oxygen. The same thing in the right, we have hydrogen, chlorine, sodium, and what? Oxygen. This arrow means production arrow or yielding arrow. It means whatever we have here is equal to here. Now let's see if that's what is correct. In the left hand side, how many atoms of hydrogen we have 2 atoms. 1 plus 1 is what? Is 2 atoms of what? Hydrogen. It is 1 atom of what? Chlorine. Chlorine 1 atom. Sodium is 1 atom. Oxygen is what? 1 atom. It's equal to 1 atom. In the right hand side, hydrogen here is what? Is 2. H2 means 2 atoms of hydrogen, so it's 2. Chlorine means what? Chlorine is what? Is 1. Sodium is also what? Is 1. Then oxygen also what? Is 1. So this is equal to this. In the left hand side we have 2 1 1 1. In the right hand side we have what? 2 1 1 1. So this equation is already what? Balanced. They just want to what? To test your what? Your IQ or your knowledge about what? This. The equation is already what? Balanced. Now note, it is 1 mole. It is 1 mole of the acid as reacting with 1 mole of what? Of the base. Please put this at the back of what? Your mind. Because we will use that. So we are through with what? BI. We are through with what? BI. We are through with what? BI. The next one is BII. Calculate concentration of A in mole per dmq. Concentration of A in what? Mole per dmq. Now you go backward to the procedure. They said A is a solution containing what? 5.00 gram of what? HCl in 500 cm cube what? Solution. Now what I want to make you understand in this is, if you look at here, 500 cm cube, that is not standard volume. It is not standard what? Volume. For it to be standard volume, it must be what? In dm cube. It means that 5.00 gram of the acid is dissolved in 500 cm cube of what? Of water, which is not standard, which is not what? Standard. It means that in 500 cm cube, the acid is containing what? 5.00 gram. It's not standard, that's not what we want. Now we will convert it to what? To standard volume. To standard what? Volume. Do you know how we convert to standard volume? We multiply by what? 1000. 1000 is equal to what? 1 dmq. 1 dm what? Q. Now see, before you will calculate mole, this is the formula for calculating mole. You say mole is equal to mass all over what? Molar mass. That's all over what? Molar mass. And if you see, we can't use this formula what? To do this, because why? The volume is not in standard. It's not what? In standard volume. Why? It is in cm3, 500 cm3. If it is 1000 cm3, that means we have to use it that way. Are you following? Yes, sir. So we have to convert this first. We convert it in what? In gram per dmq. Gram per what? dmq. Now, that is BII. BII. Conversion of A in gram per conversion of A in gram per dmq is going to be equal to 5.00 times 1000 divided by 500. Yes, watch it. 5.00 times 1000. What do you have? What do you have? 5.00 times 1000. What do you have? Yes, use the calculator for me. 5.00 times 1000. What do you have? 5,000. Eh? 5,000. We have 5,000. Divided by 500. 10. Divided by 500 is what? 10. Yes, this is equal to what? 10.00 gram per dmq. So now we have converted what to gram per dmq. We have converted what to gram per what? dmq. So we have 10.00. We cannot use this formula. We cannot use mole is equal to mass over what? Molar mass, because we have converted what to standard volume. We have converted to what? Standard volume. So what we have here, we have the So therefore, concentration of A in mole in mole per dm cube will be equal to. Now we will calculate the molar mass of the acid. What is the molar mass of the acid? From here we said H is equal to 1, chlorine is equal to 35.5. So molar mass of HCl is equal to 1 plus 35.5. 1 plus what? 35.5, which is equal to 36.5 gram per mole. 36.5 gram per mole. We know this. Our VA, volume of acid, is equal to this. Now, this is at 6.5 gram per mole. The next thing I'm going to do, we will now introduce our formula. Are you following? We say concentration of A mole dm cube now be equal to 10.00 gram per dm cube divided by 36.5 gram per mole. So what do we have? For the concentration of A, what do we have now? 10.00 divided by 36.5. What do we have? What do we have? Yes. Who is calculating the fast? Who is calculating now the fast? What do we have? Talk now. 0. What? 27. What again? What other number follows? 3. What number follows after the 3? 9. 0.274. Are you with me? That's our answer. In mole. Now you express molarity in what? In 3 symmetrical figure. You express what? Molarity in what? In 3 symmetrical figure. Right now we have 0.274 mole per dm cube. Are you following? Yes, sir. Are you following? Yes, sir. Now this is our concentration of what? Of acid of A in mole per dm cube. Are you following? Now the next one is III. Concentration of B in mole per dm cube. Now our mole formula will not work in this. We are going to what? Introduce our what? Titration formula. Are you following?
Yes, sir.
Now I will go to this. This is our CA. No, this is our what? CA. 0.274 mole per dm cube. Our what? CA. Now, III. Concentration of B. Also mole per dm cube. It is equal to, we will introduce our titration formula. We use our titration formula CABA all over CB BB is equal to what? NA over what? NB. Now in 3II, in VIII, I said calculate what? The concentration of B in mole per dm cube. Now we are going to what? Make CB the subject of what? Of the formula. We are going to do what? Make CB the subject of what? Of the formula. Please let me throw this thing. Where is the subject of our video? That's the weather we are in Nigeria. Now, CAVA is equal to CB over VB equal to what? NA over what? NB. What we are going to do, we are going to what? Make CB the subject of formula because we are asked to calculate the concentration of B in mole per dm cube. Are you following? Are you following? Yes. This is our titration formula. So let's cross multiply. We want to make CB the subject of formula. Cross multiply will have CAGA is times NB is equal to CBVB times NA. I'm sure you get this.
Yes, sir.
Now, since we want to make CB the subject of formula, we're going to divide both sides by what? VB. Are you with me?
Yes.
VB and what? NA. NA cancel NA. VB cancel VB. So therefore, CB is equal to CAVA. Sorry. Now, back to this. We are dividing both sides by what? VB and what? NA. VB and what? NA. Are you there? So therefore, CB will be equal to CAVA all over VB NA. You get that?
Yes, sir.
Now, our CB will be equal to our CA is this. Our CA is what? Is this. CA is 0.274 times 0.274 times what? What is our VA? Volume of acid. Our VA is what? 10.5 all over. What is our VB? Our VB is the volume of the base. The volume of the base is the volume of our pipette. Remember, we recorded it as 25.00 times. What is NA? What is NA? Now, this is also NB. Are you there? This also times NB. Now, what is our NB? N here and B means number of mole. This is times 1. What is our NA? Our NA is what? Times 1 also. Are you following?
Yes.
So calculate 0.274 times 10.5 times 1. What do you have?
2.877.
2.87 what?
7.
What follows again?
Not
2.877 divided by 25.00. Yes. What do you have? 2.877 divided by 25.00. What do you have? The fast, those of you calculating the fast.
0.115.
115.
What numbers follow there?
08.
0.115. After the 5 is what?
08.
Okay, we'll leave it at what? 0.115 mole per dm cube. So this is our CB. These are what? CB. Are you there?
Yes.
Are you following?
Yes, sir.
So you say, so therefore CB is equal to what? 0.115 mole per dm cube. This is our concentration of what? Of the base. This is what? Concentration of what? Of the base. Are you following?
Yes.
Now the next thing you are asked to calculate is IV. IV. They say calculate the relative molecular mass of what? Of HCl of the acid. This one is very simple. Are you there? The relative molecular mass. You say RUMM, relative molecular mass is equal to what? From here we say hydrogen is equal to 1. It's 1 plus 35.5 is equal to what? 36.5 gram per mole. So this is our final answer. The relative molecular mass, which is the weight of the acid, is what? 36.5 gram per watt per mole. So that is what we are asked to calculate. That's it. So this is all about our today's experiments. Are you following?
Yes, sir.
So we'll call it a day. Thank you very much. See you in our next class.
Thank you, sir.